Hello friends, welcome to Brainy Vibes. Today we'll be discussing a problem on how to implement a queue using a stack. So as you would already know, queue follow the principle of FIFO, that is first in, first out, or first come, first served. So you can visualize a queue as a queue in front of a ticket counter. So the person who is in the front of the ticket counter will be the one who is going to be served first. Similarly, you can stack follows LIFO principle, that is last in first out. So you can visualize stack as a stack of plate. So you would basically take a plate from the top of the stack. When you look into the operations that are involved in queue, it is NQ for inserting element into queue and DQ for removing elements from the queue. Similarly, for stack, the operations would be push for inserting element into the stack and pop for removing elements from the stack. So queue and stack are basically the way the elements are handled are different or opposite in case of queue and stack. So in order to implement a queue using stack, you basically have to reverse the stack in order to get the desired output as you would expect it from the queue. So let's see how we can implement a queue using stack. So here I am considering two stacks, a primary stack and a secondary stack. So all my insertion operation will happen on my primary stack, and all the removal operation will happen from my secondary stack. So if we were to NQ an element, say if you were to NQ1, the element 1 would be inserted into the primary stack, and again if you are NQing 2, again that will happen on primary stack, and the NQ operation on the third element will again happen on my primary stack. Now if we were to DQ an element, we should first check the secondary stack for any element. So if the secondary stack is empty, what you do is you would basically pop all the elements from the primary stack into your secondary stack, and then you pop the last element in the secondary stack as the output. Now again if you were to NQ an element, that will again happen on the primary stack. So if you were to NQ4, that will happen on the primary stack. Again if you were to DQ, the DQ will always happen from the secondary stack. So before you DQ, you check if you have more elements on, or if you still have elements on your secondary stack. If you have elements on secondary stack, the DQ operation will happen on the secondary stack. If the secondary stack is empty, you would pop all the elements from primary stack until your primary stack is empty, and then you basically pop the last element from the secondary stack as the output of the queue. Now the next operation is another NQ, so that again happen on the primary stack. Now if you were to DQ, as we had an element in the secondary stack, we basically popped that element from the secondary stack. Now if you want to again DQ, since the secondary stack is empty, we basically popped all the elements from the primary stack, and you pop the last element from the secondary stack as the output of the queue. Now the last DQ would basically pop the last element from the secondary stack. So this is how we implement a queue using stack. Now let's see how you can implement it in code. I'm coding it in Java. In the interest of time, I've already implemented it. I'll just walk you through how the implementation is done. So I have declared two stacks, a primary stack and a secondary stack. So since we are implementing queue, the operations would be NQ for inserting elements into the queue, and DQ for removing element from the queue. So in the NQ operation, we are basically pushing the elements into the primary stack. And for the DQ operation, what we do is we'll first see if the primary stack and secondary stacks are not empty. We have to make sure that we have elements in at least one of the stack. If both the stacks are empty, then you need to handle it so basically I'm throwing a null pointer exception. You can handle it however you want to handle it. You can throw a meaningful message to the user. And next you have to, like, if you have elements on your the secondary stack, you can basically pop element from the secondary stack. If you don't have elements in your secondary stack, that is when you have to pop all the elements from the primary stack as long as until your primary stack is empty, and you basically pop the elements from the primary stack into your secondary stack. And at the end of the while loop, you basically pop the last element from your secondary stack as the output of the queue. We'll see how we'll just test and see if this code functions as we expect. So we have a primary stack and a secondary stack, and then you basically have the output. So let's NQ1. So that will happen on the primary stack. So 1 will be inserted into the primary stack. Now we NQ2, that will again happen on the primary stack. Now we NQ3, that will again happen on the primary stack. Now if we were to DQ, so the DQ, when it comes to the DQ, we'll first see if both the primary stack and secondary stacks are empty. So even though the secondary stack is empty, the primary stack is not empty, so it will not go inside this if loop. Now if we are checking if the secondary stack is not empty, so since secondary stack is empty, it will go to the else loop. And as long as the primary stack is not empty, we are popping elements from the primary stack and we are pushing it into the secondary stack. So what happens is where it will pop the element 3 first, and it will insert into the secondary stack. Then it will pop 2 and insert it in the secondary stack, and then at the end it will pop 1 and it will insert it into the secondary stack. And at the end, once that is done, we basically pop the last element from the secondary stack as the output. So we basically output 1. Now again, if you are NQing NQ4, that will again happen on the primary stack. So 4 will go into the primary stack. Now if you NQ5, that will again go to the primary stack. And now when you DQ, when you DQ, we'll go check if both the stacks are empty. If it is not, then we'll go check if the secondary stack is empty. At this point in time, the secondary stack is not empty, so we'll basically pop the element from the secondary stack. So we'll basically pop 2, so the output will be 2. And then again, if the operation is DQ, we'll basically check if both the stacks are empty. No, come here. We'll see if secondary stack is empty. It's not empty, so we'll basically pop 3 from the secondary stack. Now again, if you DQ, it will come here. Now this condition is not satisfied. Now our secondary stack is empty, so it will basically go to the else loop, and it pops all the elements from primary stack as long until it is empty, and push it into the secondary stack. So basically it pops 5 and it insert into the secondary stack. It pop 4 and it insert into the secondary stack. And and finally it basically pops the last element from the secondary stack. And at the end, if you are going to do a DQ once again, it'll pop the last element from the secondary queue, and we have the expected output from the queue. So when you consider the worst case complexity of this algorithm, it is going to be order of n here. So if you are basically pushing all the 5 elements into your secondaries into the primary stack, and at the end of the operation you are choosing to pop the element, it basically have to pop all the elements from your primary stack into your secondary stack, and then finally output the last element from the secondary stack as the output. So basically the worst case complexity of this algorithm is order of n, and even the space complexity would be order of n. So this is how the implementation goes. If you like the video, kindly like and subscribe to my channel. I'll be solving more problems in the future, and your likes and subscription will be an inspiration for me to do more problems. Also, if you have any specific problem that you would like me to do, you can post that in the comment, and I'd be more than happy to solve it. Thank you.